Good morning, everybody. Thank you for joining us today. We're going to do a short introduction. This is Nate Rett with JMT, and he will be our next presenter. And told him I'd give him as much time as I could.
Thank you, Leilani. Morning, everyone. My name's Nate. I am with JMT Technology Group. Just a quick rundown. JMT Engineering Group, we have the technology group inside, GIS, IT, data management, BI, other aspects. Esri partner, soon to be a gold partner, Trimble partner, and then we're really proud of our GIS staff. We have 18 GISPs on staff doing a lot of work, and we do have 6 offices here in the state. The technology group is somewhat new to North Carolina, but myself in my previous life, I did work with the DOT a fair amount. So I'm going to highlight some of those opportunities and some of the things you can do with spatial data and the outputs. If you were in the last session, Nikki's session was strategic planning. This is going to show some of those outputs from that strategic plan. Like, what are the tools that you might need? What are the processes you need to answer some of these questions? And I was at the Esri conference, the partner conference last week, and we all know what GIS is. If we're not, we shouldn't be here. But Jack Dangerman gave his keynote, and one of the things he said is that GIS is not just the science of where, it's the science of everything everywhere. And it's basically the truth. Everything we have can be located now. We have the ability to collect that information, and what can we do with it? Now, pure data analytics, you can answer a lot of questions. But you bring in the power of spatial analytics, which I know a lot of us do on a daily basis, you can answer very pointed questions. And me being a transportation guy, I always like the one that where you get a question from an engineer or a project manager that says, I need to know where I have projects that are being covered by bad IRI values or roughness values that we're doing widening in the area that we can pull in other projects and consolidate costs, okay? That's a pretty detailed question. But if you have the ability and you have it all mapped out, it makes it a lot easier than trying to, the old way of Excel work-throughs and trying to do pivot tables and everything else to make it all work against your network. Could be your water network, it could be your road network, it could be just anything from retail down to education. So what I want to do is I want to show some of the examples that I've worked on personally and some that our staff have worked on over the years to answer some of these questions and what you can do with spatial analytics with different types of technology, be it applications, services, you name it. And so just some examples of what spatial analytics really can do for you is it's the ability to ask the questions of where, right? So if we look at emergency management, which is a big topic, I know you all have been through that personally, and looking at transportation modeling or looking at detours or crime or whatever, they have the ability now with even more advancing technology. Esri rolled out their announcement of their GeoAI framework last week and had some pretty cool stuff in it. But it still has a long way to go. But I sat in on a presentation by the head of Deloitte, and he gave a keynote at a data analytics conference that talked about what is AI, right? And AI is really just the next iteration of what computers can do to help get rid of the muck work. And I like that analogy because back, if you think about it, before Lotus Notes showed up in Excel, everything was done by hand calculations or whatever. That line coming in of that work being covered by Excel or formulas on your computer, that was considered, in his view, AI. It was the next iteration of what computers can do. This iteration coming up with more spatial analytics from Esri, some of the AI functions that are out there with large language models, imagery models, those things, is just that next muck layer to get out of our hands so we can do the next thing. And so I want to show some of those examples, but also at the end here, I want to give a very specific example of a watershed mitigation example of the steps that we ran through to do that. So just from a perspective of what really spatial analytics and just the ability to overlay your data in a lot of different fashions now sets the table for being able to do this. So in this example, this was one where we had LiDAR from the surface. We had engineering models or as-built, and we could overlay everything in one picture with your GIS data, being able to provide a different picture to the engineers. And I'm going to get into some examples of where you can then take that with AR, VR out in the field, and in our next presentation in the next half hour is all on that topic, so to run into more examples. But if we look at, go to the next slide, just some examples. So there's a lot of stuff out there, public websites, individual specific applications built, campus viewers, indoors, GIS is a big topic these days, and being able to bring all that into one space to then visualize and analyze is the key. So there's a lot of custom applications out there doing this. Esri has a full suite of COTS products, configurable out-of-the-box products that you can then do these things. But the different types of analysis that you can do, from utility management to campus or facility management to figuring out projects, how they relate to road condition and those things, and the ability to bring in extra data sets on top is really what is driving a lot of the organizations these days, especially DOTs, environmental departments, those things. And to do a lot of this stuff, the cost is coming down, right? Because the technology is now more self-service. GIS is now becoming a self-service setup with what Esri has and some of the other open source products. But it takes a lot of knowledge to understand what your data is to answer the questions that you want to ask. Because you can ask a question, you might get a wrong answer, but do you know it's wrong? So without knowing your data, you could get a wrong answer and then put it out on a report that then somebody else is picking up, and it's not a great scenario. So data quality is huge. I could do a whole discussion on data governance and data management, but once you have that, then you can build applications, tools to look at very specific items. Like this was based on, this is a map from Pennsylvania where I did some analysis with their 511 system, with their road closure data after a flooding event to figure out where public buses would be able to route around. Okay, this was from the DOT's perspective on how they were helping the school districts figure out based on that data. So being able to overlay the severity data of the floods, their damage assessments and everything, they were able to come up with new detours around in a pretty rural area. And some of those detours are pretty far. So they had to figure out how to bus the kids around and still get them to school on time. So the DOT was working with education to figure that out. So that was a good just GIS process example. Of course, there's counties in Maryland and some other states that like to put out their crash data. So, and it allows the public to go in and do some analysis with demographics. So they can look at crash hotspots compared to environmental factors, compared to demographic factors, social justice factors, and then the planning and programming groups within an organization or even the planning partners can then use these offered services from the county or from a city, government agency, whatever, to do some of their planning without having to go to them and ask for it. They're providing it out. And a lot of the analysis is already done. So that's the cool part of GIS now is basically everybody's sharing everything, which is good. Again, make sure that the data's good and it's what you need and you're understanding what it's telling you. Because if you pull out hotspot data from crashes, you could very easily misinterpret that as that's how many crashes might be in that area, and it could be a severity level of crashes in that hotspot. So just make sure you kind of understand what's going on. There's like ArcGIS Hub abilities now that you can tie in a bunch of different data together to come up with viewers that allow you to do the on-the-fly 3D spatial aspects of your infrastructure. So like for an example, this is an airport example where you can bring in the Autodesk and Revit models, you can bring in Maximo data for work orders, and they tie it all into their enterprise GIS and give the ability for their facilities unit and their managers to go in and look at different details of the airport, what work's going on, being able to look at then and bring in the 3D models on top for some of the generators or a cooling system or whatever. But then, once you have that, and this is an example not exactly of that situation, but then again, you can have the AR/VR view in your hands, walking around the airport and see what's in the wall. If you have it referenced correctly, you can see what work orders are going on. You can see different aspects if there's QR codes, and we'll explain a little of that in the next session. But being able to have all of that in your hands now and be able to do that analysis on the fly to see what's in the floor, see what's in front of you, is tremendous time savings and allows you to put GIS out into the hands of people that normally wouldn't. And that's really what our goal is as a GIS community, is to empower others to use the stuff that we create to do their job better. So one example of where the spatial analytics came in from a as-built model to a utility network model to then just the general GIS is the ability to do conflict detection for utilities. So being able out in the field to walk around after we load the ads built in and then come up with the line work from the utility network itself and overlay on the street as you're walking around, you can see where the pipes are underneath without having to dig. We have a project and we built a system for Pennsylvania's 811, which is their PA1 call, that allows the 811 folks to look and see where utilities are from a GIS perspective before they go out in the field. Okay, so that's a statewide initiative that they put together. But this is just an example of being able to do that in the field with tools like from VGIS and some other ones that just allow you to do it in the palm of your hand that fast. And being able to then overlay other data on top of it while you're out there. If they say, okay, there's a work order in this area, which pipe is it, and I can see it, that's awesome, right? The other aspect is situational awareness. So a lot of this is the spatial analytics in the background to come up with these outputs. Now, for example, you can have in the top right your sewer and water inspections of your program going on, how much money you're spending from the financial system brought in. You can then do spatial analytics to see how much work is happening in a specific area or in a specific service line or a trunk, or do you have a specific meter type that keeps failing, and where are those, and what's different about the soil there that's different, that's causing some of that possibly. The bottom then you can have more of a transportation flare, which is what is their program doing from a maintenance standpoint or a capital program perspective. Traffic management centers. I used to sit in one, and to have tools like this that are all kind of rolled up to be able to look at different data sets on top of each other and then say, okay, if we have this amount of rain coming, very example of what's happened here, is being able to predict some things, but also to look at CCTV cameras on the fly, those kind of things. Just bring it all together, and then you can answer questions together from an operator's perspective. So I wanted to take about 5 minutes to do a deep dive into a very specific example, just to kind of give you the front to end. This one was a pilot project. It was to determine the costs and the mitigation credits between projects and how they were impacted by potential wetlands that they did not have identified. So trying to predict where the wetlands were, looking at budgets and how they all aligned. So this had modeling in it. It had the use of ArcHydro. It had other aspects that I'll walk through. But the interesting part about this one was because it was a pilot, we did a small area of the state, and was able to look at the lessons learned of it then, because if we were to do this project again today, we'd do it differently. We'd use a different set of models, different set of things, but this was the pilot to do this. So this was a good example of how to cut your teeth on a new process of doing water mitigation prediction areas. So looking at curvature, looking at topography, looking at the wetness index available, all the different pieces, and then using the WIM models out of ArcHydro to create the predicted areas with all of that data, then counteracting that or looking at that with some of the other LiDAR data that they had available to kind of pick out these areas. We were then able to take a project, so this was a road project, being able to overlay those predicted layers and predicted wetlands, bring in then the existing stream data set that they had, bring it all together, and then clip it out. So they do it by buffer on those things, and they say, okay, these are all the impacted areas that I'm gonna have coming up, right, with this project. Then what they're able to do is apply all of the other ecological factors, compensation factors, money, all those things to those projects that then ultimately spits out, when they ran the whole system of all the projects in that area, they're able to then build a dashboard out that says, okay, here's where I have to horse trade credits and say, this one is more expensive, or I need this credit over here to do this project. I'm gonna then work in my plan to move those around. And it gave them that ability, which would have taken them months to do, in like a week, right? So if they ended up doing the whole system, that's a lot, that's a ton of savings, and they find out information quickly based on the data they have. Now, going back to where the prediction was happening with using ArcHydro WIM models and those things, talking to the developer the other day of this, she's very much in the view now that she would love to have used some more newer machine learning models to figure this out instead of some of these ways, because it wasn't as accurate. And it's advancing every day. I mean, you guys know that. So as the new models come online, because it's a pilot, now they can go back and try the next one and see how well they did, right? But it all comes down to this type of view at the end. Being able to say and answer the questions of, okay, where do I have to spend money, or what do I have to change? If you go back to any of those other dashboard examples or apps, that's exactly what they're doing. And I wanted to ask at the beginning of the session, I forgot, but how many folks are county-based, okay? City, town-based, okay? State agency, okay? Private, okay? Great breakdown. Again, all of this stuff is applicable to all of you in here because the tools available now allow it fairly quickly, but the modeling that you would have had to do 3 years ago is now an automated process, and you can start automating, and that's the thing now is I have data, I get a survey 1, 2, 3 form in, I need to automate that to go somewhere using Power Automate or Workflow Manager or any of those. You're taking that muck work out of the middle and allowing you to answer and do questions on your own that normally you wouldn't have time for. And that's our goal. That's AI's goal at the end of the day, is to free up people's time to do the bigger items. And so I just wanted to show a few examples here. If you do have any questions, let me know, and be happy to answer them. But I just wanted to give a overview of what is happening in the different areas of government and things that I've seen and our team has seen over the years, just to give a taste of things. And then go back. Esri has training for all this stuff to do these things. There's peers to talk to. I mean, this community is great. GS community is wonderful because everybody helps each other out. They talk, those things. We're sharing all the time. Do it every day. So Thank you.
Do you have any questions for Nate? Of the presentation? Yes.
I was just wondering, could you go back to the slide where you were overlaying the three? You said you did the arc hydro, curvature, and LiDAR.
Yes.
What else did you do?
Uh,
So just those two, the depth to water ratio. That's what it was.
yeah, it was depth to water ratio. Yep.
I still asked you. Thank you.
No, you're fine. Yeah. So we ended up actually being able to generate from the 4-band imagery as well. So we had all kinds of different choices that they had available, and then we could always go out and fly whatever we needed to cover any other data we needed. But they had a bunch of data available for us. So, anything else?
Any other questions?
Awesome.
Did they do statistical analysis of the, like, accuracy of the wetland modeling?
I don't think we got to that far. I think the owner, once they saw the results of the pilot, they kind of said, well, I don't think we're ready for that yet. So our team would love to do it, but they just haven't said, yeah, go ahead and do that. But we never went back and did the statistical part of it. So, Connor.
What's your opinion on the arc hydro tools, like compared to other tools?
I don't have any specifically because I haven't used it myself, but our developer who has, she would love to talk about it. So she loves to just talk all that stuff. So let me hook you up with her and she can talk all day about that stuff. She's our wetland modeler. So anybody else?
Any other questions?
All right. Thanks, y'all.